Hey, let's discuss this problem. So it's also a 1800. So let's begin with the example here. So in the example, we are going to have two numbers. The first number is the number of people here. So the array here denotes a array of people. And the second number is the number of teams. So in this case, we have one people in team one, two people in team two, three people in team three, right? So in the second example, there are 10 people in team one, right? They're all from the same team. And what are we going to do with these people? So we are going to transport these people to another place. So they will take a bus. And the way we put them into a bus need to satisfy two conditions. The first condition is that one team must be in the same bus. So we can't put a team member from team one in one bus and another person in team one into another bus. So the same team must be all in a same bus, right? That is the first condition. And the second condition is that one bus can at most hold two teams, right? Uh, there are at most two teams in one bus. Actually, there is another constriction that is all of the bus's capacity is the same. So let's say um, we have a bus with three capacity, right? So S here is the capacity of all the buses. So each of the bus can carry three people, right? So if we can choose any S here. So the cost of choosing the cost of using a bus is S multiplied by the number of buses, right? So R here is the total number of buses we need to take all of these people to the destination. So in the first example, let's say we set S equal to 3. Then in the first bus, we are going to have um, team 1 and two team 2, right? So the first bus is 4. And in the second bus, there are 3 people from team 3, right? So the total number of buses we need is 2. So R here equals to 2. And S here equals to 3. So the total cost is 6. And this has to be the minimum cost. So here, obviously, we don't have better solutions. So we output 6 here. So what if we choose S equal to 2? So in this case, the team 3 have to be separated. So that is not satisfy this condition, right? Because the people from the same team must be in the same bus. So that is not gonna happen. So what about s equals 4? In that case, we still only need 2 buses, right? And each of them cost 4 now. So the total cost is 8. It's bigger than this guy. So still, the optimal answer is 6. And how do we solve this problem? So we are going to use brute force search, right? So there are only so many S we can choose, right? What is the worst S we can choose? That is the biggest team. So the number of people in the biggest team, right? So in the first example, the biggest team is team 3. There are 3 people in team 3. So the worst S we can choose is team 3 because we cannot separate the one team into different bus. So this is the minimal S we can have. That is not actually the worst. It's just the minimal S we can choose from, right? So what is the maximal S we can choose from? Um, that is the biggest team uh, plus the second biggest team, right? Why is that? Because in one bus, we can only hold 2 teams. So let's say what is the maximal capacity of a bus? So we can just consider the worst case. We put the biggest team in the bus, and then we put the second biggest team in the bus. So that is 5 here, right? So this range is not so big. So let's see. Let's take a look at the problem here. So at most, we are going to have 5 multiplied by 10 to the power of 5. So that is the maximal teams maximal capacity of a team, right? So the maximal capacity of a bus is 10 to the power of 6. So that is actually not that big. So we can just brute force through it, right? So let's say we already choose the S, and we need to decide um, what is the cost for this specific S. So we need to calculate the cost for each S, right? And choose the minimal cost. So now we only need to calculate the cost of each S. So how to calculate it? So let's say we have S equal to 3. That means the capacity of our bus is 3. So in this case, we are going to sort the teams from big to small, right? So we have the biggest team. Team 3 has 3 people. And the second biggest team, 2, has 2 people. And the third biggest team, Team 1, has 1 people, right? So first, we are going to put the biggest team into the bus. right? So we put three threes into the bus. And to check if we can push the smallest team into the bus as well. So in this case, we cannot because the bus is already full. So we are going to try the second largest team into another bus, right? So in this case, we put these two twos in the second bus and check if we can put the smallest team into the bus as well. So in this case, this bus can carry the team one still. So we push team one into the bus as well. So to simplify that, first we are going to sort the teams from big to small, right? And then we are going to push the biggest team into a empty bus and check if we can push the smallest team into the bus as well. So why is that? It is because if we cannot push the smallest team into the bus, that means we cannot push other teams into the bus as well, because currently this is the biggest team in the bus, right? Uh, if we cannot push the smallest team in, we obviously cannot push the bigger teams into the bus. So if we can push the smallest team into the bus, so we must do that because it's better to push the smallest team into the bus than just leave it outside, right? Because we want to make use of the empty space in this bus. So another question: why don't we just push a little bigger team into the bus? The reason is that um, if we push the a little bigger team into the bus, that means um, the smaller team must push into another bus, right? If the smaller team push into another bus, that means a little another team with a little bit smaller size than the biggest team potentially need to be in this bus as well. So in that case, we still have four teams in two buses. Um, it's not better than we have the smallest. It's not better than we switch these two teams position, right? Because if the let's see, if the bigger team can work with the biggest team in one bus, that means this guy can take a place of this guy as well. So um, if this guy cannot fit in this bus, that means actually, let me try this again. 1 second. So the question is that uh, if we push a biggest team into a bus, um, can we push the second smallest team into the bus so that we can get a um, more optimal solution in the end? Let's see. So let me try this again. So let's say we have four teams and we sorted according to the number of members in the team. So team A has the biggest number and team D has the smallest. So in this case, we are going to choose A and D in the same bus. And potentially we can choose B and C in the second bus, right? Why don't we choose A and C in the first bus and also choose uh, B and D in the second bus? Would this option be the optimal in some cases? The answer is no. Let me prove it. So if we want this guy be the optimal, that means this guy must have has three buses, right? So this solution must be like this, right? So, but this case will never happen when this is the case. Why is that? Because um, A, we have this case because B and C in separate buses. That means B plus C is bigger than this bus. But this solution clearly says that um, A plus C in the same bus, right? So this guy is small or equal than S. And here we are saying that B plus C is bigger than the bus, right? And A is bigger than B because A is the biggest team of all. So that this guy should be smaller than this guy. So there is a contradiction because the smaller guy is bigger than the bigger guy, right? So that is a contradiction. So with that being said, this will not ever be better solution than this solution. So we so the best solution will always be choose the smallest team each time, right? So with that being said, it's easy to calculate the final score, final cost here. Just use the algorithm, put the biggest team into the car and try the smallest and put another biggest and try the second smallest, right? Until all of those teams are on the bus. And thus we can get the number of buses and just multiply by S. We can get the uh, the cost. So after we get all of those costs for each S, we can just choose the minimal cost. So let's take a look at the code here. So first, we are going to calculate the size of each team, and then we're going to sort the teams by the size. Then we're going to try all of those S and calculate the cost for each S, right? And we are going to have a left pointer and a right pointer. And we keep the number of buses here. And this is where we choose the biggest team, which is pointed by left pointer, and the smallest, I mean, left pointer here is the smallest team, and the right pointer here is the largest team, right? In the end, we are going to calculate the answer and update the answer here, right? Uh, so that's it. I was confused myself during the explanation. So sorry about that. See you next time.